This is the last lesson of notes in Calculus 1 for us. So lesson 5.9, hyperbolic functions. You definitely want the pink sheet for these notes today. On our pink sheet for our formulas, we have a lot of rules for hyperbolics. I know you can't read it through this video right now. This is rules 7 through 12 are all your derivatives of your hyperbolic sine, cosine, and cosecant. And rules 13 through 18 are your derivative rules for all your inverse hyperbolics. So you definitely want to have that sheet out in front of you, and we'll be referring back to those as we do these notes today. So first off, we want to first define out what our hyperbolics mean. So the hyperbolic sine of x is defined to mean this right here. It's e to the x minus e to the negative x over 2. And hyperbolic cosine is defined to mean that. Hyperbolic tangent will be hyperbolic sine over hyperbolic cosine, your cotangent, your secant, and your cosecant. Those resemble our other rules as well from trig. Hyperbolic sine of 2x, hyperbolic cosine of 2x. And then here's looks like the Pythagorean identities. They're a little bit different in hyperbolics. And then here you go again. So these right here, you guys are going to want to probably use that slide as you're doing your homework. And we'll really pretty much stick to the derivatives for the hyperbolics for your test. Other than that, you're not going to see these. So find the value of 3 decimal places for hyperbolic sine of 3. So again, like I said, not on the test, but for your homework, you are going to need a calculator for this. So the hyperbolic sine of 3. So you're going to put e to the 3 minus e to the negative 3 over 2. You literally are going to plug a 3 in for each of those x's, get your decimal. So hyperbolic tangent of negative 4. So that means I need hyperbolic sine of negative 4, then hyperbolic cosine of negative 4. That means I need the sine function divided by the cosine function. Well, the 2's would cancel, so I really just need this numerator, and then that right there would become a denominator. Type in the top, and then divide by the bottom, but you got to make sure you do parentheses appropriately, or you will end up getting this incorrect. All right, so if I am given the hyperbolic sine of x is 6/5, find each one of these. All right, so I was given these identities right here. So the hyperbolic sine squared, if I add that over to 1 and then take the square roots, that would be my hyperbolic cosine. So I add the 36/25 over, take the square root of that. The hyperbolic tangent would be hyperbolic sine divided by cosine. So the 5's would cancel, it would be 6 over radical 41. Hyperbolic cosecant was the reciprocal of the sine, so 6/5, 5/6. Hyperbolic secant, reciprocal of the cosine, 5 over radical 41. Hyperbolic cotangent, reciprocal of the tangent, radical 41 over 6. All right, now I want the derivative of the hyperbolic sine of x squared minus 3. So now go to look at your pink sheet. These I do put on my test. So first I have to find the derivative rule for the hyperbolic sine of u. Rules number 7 through 18, which rule number is that? Hopefully you're thinking that's rule number 7. That would be correct. So your answer would be the hyperbolic cosine of your u, which was x squared minus 3, times the derivative of your u, which is 2x. All right, I want the derivative of the natural log of the hyperbolic cosine of x. So the derivative of the natural log is du over u. So that means I need the derivative of the hyperbolic cosine of x on top over hyperbolic cosine of x on bottom. So the derivative of the hyperbolic cosine was going to be the hyperbolic sine of x. If you take a look at rule number 8 for that, and then sine over cosine would simplify to the hyperbolic tangent of x. All right, this time I want the derivative of x times the hyperbolic sine of x minus the hyperbolic cosine of x. So this piece here I have to do the product rule with. This one, just straight off the pink sheet. So x, derivative is 1, sine, hyperbolic sine its derivative, cross multiply, add, and then this one's derivative. Notice these two are the same terms. Those are going to cancel out to 0. You're going to get x hyperbolic cosine of x. Find the derivative again. So this is a coefficient, hyperbolic sine of 2x. That's going to be rule number 7, where your u is 2x. This derivative is just minus 3/2. Okay. And you could factor out the 3/2. Then you could have that, hyperbolic cosine of 2x minus 1. Hyperbolic cosine of 2x minus 1. Hyperbolic cosine of 2x minus 1. You multiply the 2 over here, that'd be 2 hyperbolic sine squared. So Either way you do that, it doesn't matter. This answer's right. This answer's also correct. This is going to be chain rule. You're going to take 2 times everything in there to the first, and then times the derivative of what's in there. Now, the derivative of what's in there, the hyperbolic secant, you go to your derivative sheet on the pink sheet, and that's going to be rule number 11. So again, we said we had 2 times everything into the first times the derivative of what was inside. So that I needed the rule for the derivative of the hyperbolic secant, which is negative hyperbolic secant, hyperbolic tangent of du, meaning the derivative of the 9x, which was a 9. So I have 18 negative, and then hyperbolic secant squared, and then the hyperbolic tangent. All right, this time I want the derivative of the inverse of the hyperbolic cosine. So the derivative of the inverse of the hyperbolic cosine. So the derivative of the inverse of hyperbolic cosine is going to be rule number 14. So I need u prime over the square root of u squared minus 1. Your u is 2x, so the u prime would be 2. And then I need u squared, so 2x squared, and then the 1 and the square root. So the derivative of the hyperbolic sine, what rule number do we need? That's going to be rule number 7. The derivative of your du would be negative 6 dx. Okay, so in integrating this, if u is 1 minus 6x, then the du is negative 6 dx. So I need negative 1/6, the integral of hyperbolic sine of u. See, so we're looking for the integral, the derivative of what is the hyperbolic sine. The derivative of the cosine is the hyperbolic sine. That's why I'm getting negative 1/6 hyperbolic cosine of u. Plug back in for your u plus c. Because remember, the reverse of the derivative is the integral. Alrighty, so which one do you think might need to be your u? Because we're going to do a u substitution here. So the u needs to be the hyperbolic sine of 2x. Because it's the one that's raised to the power, and this one is not. And the derivative of the hyperbolic sine would be the hyperbolic cosine. But I do need a 2 dx with that. So I need a 2 here, so I need a half out front. So it's a half the integral of u squared. So that's going to be a half of u to the third divided by 3. That means 1/6 of u to the third plus c. Plug back in for your u. The integral this time. So if I let u equal the denominator, then the du happens to be what's in the numerator. So I have du over u. If I have du over u, the integral of du over u would be the natural log of the absolute value of u. So that would mean the natural log of, plug back in for your u, the hyperbolic cosine of x, and then plus c. Solve the differential. That means we need to integrate both sides. So y equals the integral of the numerator over the denominator dx. If I let u equal the entire bottom, my du would be 4 minus 2x. If I multiply that by 4, I get that, but then that's not gonna do it. I'm not gonna be able to get my du in the numerator. So I know I need to go back to maybe doing some completing the square. So we're gonna try that back what we did yesterday or a day before. So I factored out the negative 1 there. Half of that is 2, squared is 4, and 4. Factor it. U equals x minus 2, my a equals 4. I'm leaning towards integration rules either 1 through 6. So it's looking like I'm going to have a squared minus u squared on the bottom with no square root. So it's looking like rule number 5, where a is 2, u is x minus 2. Okay, so again, it looks like rule number 5. But the problem was here, right here, guys, I've got 1 minus 2x. So I have 1 minus 2 times the x. X would have been u plus 2. Distribute and finish adding like terms. So this one is rule number 5 on the integration rules. Factor that negative 3 to a coefficient. This one's ready to go. This one is not ready to go. Now I have to do a w substitution. So w for that denominator, its derivative would be negative 2u du. See, this right here is my dw over w. dw over w is going to be natural log of w. Natural log of w, that means natural log of the w, which was a squared minus u squared. So natural log of a squared minus the u squared. This piece was negative 3 times, and then we integrate using our rule down there for number 5. 1 over 2 times a, so 1 over 2 times 2, natural log of, and then it says a plus u on top, a minus u on bottom. And there's our final answers. And both of those are correct answers. I want you to realize that negative coefficient, this positive coefficient. That just meant they raised it to the -1 right here. Raising something to the -1, you would take its reciprocal. So just wanted to let you see the other version of that answer. Find a relative extrema means to find when you have maximum minimums, when it's changing from positive to negative and not at an asymptote. So we'd have to take our derivatives. So this first part of this derivative here was product rule. That derivative was just plain simple. And when does it equal 0? Well, the hyperbolic cosines are gone. That leaves me with this factors here. So that's when x equals 1, or when hyperbolic sine of x equals 1. I mean, sorry, 0. My bad. So x equals 1 is a critical number. When will this ever equal 0? We'll multiply by 2. So I still have 0. That means when e to the x equals e to the negative x. Well, that's only going to happen if x equals negative x, therefore only when x is 0. So those are my critical numbers for my first derivative number line test. And once I find these two numbers, then I plug into the first derivative to find out where it was positive or negative. Definitely not on my test. We've not seen this on the final, and this one's a pretty complicated question over the years. And this happens to be what the graphs of your hyperbolics look like, in case you were curious. So the hyperbolic sine of x, the hyperbolic cosine of x, a hyperbolic tangent. That almost looks like the arctangent. Hyperbolic cosecant, hyperbolic secant, and then hyperbolic cotangent. The inverse hyperbolic functions, this is what the graphs would look like as well. Hyperbolic function summary. These were the rules that we were using. And the end. We have finished our notes. Fireworks are going off. Y'all have an awesome day. We'll see you tomorrow.